And welcome to the presentation today on virtual storage and real data recovery. Thanks for joining our webinar, and hopefully some of you have been in our webinars in the past. I think our last one was back in August, and we were probably talking about cloud computing at that time, which is an excellent segue into what we're going to talk about today, moving forward with virtualization. As John remarked, I'm a senior enterprise recovery engineer here, been around DriveSavers for quite a while, as has John, and we've seen all kinds of things happen in the storage world, and lots of stuff is happening related to virtual machines and virtualization today. I'm going to try not to dig too deep into the technology because it would be very exhaustive to go there today, but my goal is to explore a high-level view of what you need to know and why. We'll leave time for Q&A at the end. Make sure that I can answer any of your questions, and any that I can't answer I'll take offline to our VMware Enterprise Engineering team, who is in the trenches doing these recoveries for you and your customers every day. So with that quick introduction, let's get started. And if any of you have been here before, you remember that I always like to start out with what's new in the DriveSavers world and in the data storage world. And of course, in the last 2 weeks, unless you have been asleep, you know all about Superstorm Sandy and what has gone on, unfortunately, on the East Coast. That particular storm did some very serious damage. And as of today, there are still major buildings in New York City without power. I heard last night on NPR that there are 65 large buildings still without power in lower Manhattan. Unfortunately, many houses, many businesses were destroyed, and much of their data went with them. We've been receiving calls since the morning of October 30th for recovery from these devices, and we've helped. Gosh, we've had hundreds of calls so far. Single drive users through banks and hospitals with small RAID systems. And the good news is we've been recovering these systems that were submerged, as well as many other power-related failures, which is actually driving a lot of the data loss more than the water itself. And we have our special discount offer, which you should all be aware of, which is a $500 off discount on any single disk recovery, one per company that would have been afflicted by Sandy. So call our 800 number if you have any questions about that at 800-440-1904. Of course, one of the why this is so relevant to what we were talking about last time was about the availability and the redundancy and resiliency of cloud providers. Well, unfortunately, Mother Nature takes out cloud providers just like she does single hard disks. The screen you're seeing right now was put online by Gawker Media, who runs lots of websites. When they were down in this data center, that was in southern Manhattan, and at least 4 data centers, Internap, Pier 1 Hosting, Datagram, and Steadfast, all went offline. These were redundant data centers with multiple power supplies and all kinds of stuff to prevent them from going down. Nonetheless, they all went down. And guess what? They were probably all running some level of virtualization software in those DCs. So what else is new at DriveSavers right now? We just released a new security white paper just a couple of days ago, and you can download it at this link right here, or visit our webpage to go ahead and do so. And go ahead and read this white paper and learn more about recent studies and stats on the vulnerabilities of the data recovery industry as a whole. This is really good stuff for administrators and those involved in data security, or anyone using outsourced providers to manage customer or user data. We're always about protecting the user data during the data recovery process, and this white paper helps alert you to some of the things you need to be aware of. And lastly, in the what's news category, of course, Apple had a couple of announcements in the last few weeks. Not unexpected was the iPad mini. We expect to see more of these in the laboratory for recovery than regular iPads, simply because of the mobility of them, and they're more likely to be dropped, smashed, or fall into water. For the same reason we do a lot more iPhones than we do iPad recovery. Plus the cameras, there will be content generation on those devices. The good news is we don't expect any technological challenges for this particular device because we know this infrastructure quite well. But what is very exciting, of course, is the new Fusion drive for anybody out there who's a fan of Apple technology. Apple has taken an enterprise-level technology down to the consumer, which is the combination of solid-state drive and hard drive on new build-to-order machines and on any machine, I think, running 10.8.2 that can support it, where they figure out the greatest advantages of SSD and marry those through some logical software called Fusion Drive to the higher capacity of a hard disk. The great news from a recovery perspective is we're already well familiar with this type of stuff, and we've been testing it in the R&D lab, and we know that we can recover from either side of a Fusion drive if it breaks, but we will in fact need both the SSD and the hard drive if we do a data recovery for one of your customers. So that's it for the what's new stuff, and let's get to the meat of the discussion today and why you came to the webinar, which of course is to talk about virtualization. So let's define it first, just so that we have a level playing field starting out. So virtualization is really the creation of a virtual rather than an actual version of a hardware platform, operating system, storage device, or network resource. More simply defined, it's the ability to run multiple guest virtual computers or OSs simultaneously on a single CPU computer or host. So that's the quick definition of virtualization, at least related to computing. But when we get into it a little bit more, the most common term that you're going to be familiar with is the hypervisor. It is the most integral part of a virtualized computing or storage environment. And simply, the hypervisor is the software, firmware, or hardware layer that creates and runs the virtual machines. Hypervisor is a term used primarily by VMware, but a couple of the others. It's also referred to as a virtual machine manager. And again, this is the layer of software, firmware, or hardware that you build the virtual environment on top of. So let's visualize this for a second instead of just seeing it in text. What does it really look like? Well, it's fairly simple from a visual perspective. On the left, you'll see the traditional architecture of computing, which had a hardware or a computer on the bottom of the stack. That was the host. An operating system, sitting on top of that, whether it be Linux, Unix, Windows, Macintosh, whatever it might be, and then your application or applications riding on top of that. This has been computing for a very long time. This is the standard model. However, on the right side, you'll see the architecture of a virtual environment where the bottom layer is the same. What we've got is today's modern hardware with lots of processing power and lots of memory, but instead of that traditional operating system sitting on the next layer, the hypervisor takes its place. In this diagram, it says VMware ESX. That is the hypervisor layer in this particular case. And the benefit, as you can see on top of that, is there's not one application running. There are 6 different operating systems, or as many as you want, Linux, Windows, whatever, and then applications running on top of those. So in the virtual model, we can see that you have many more options that can run on that same piece of hardware with that hypervisor layer in between. So let's look at the history of virtualization for a moment. And I actually found this a fairly fun exercise to look through this. And anybody who's been around in computing for some time will probably recognize these milestones. But just like every other good technology in storage, IBM pretty much invented it in the 1960s when they were inventing all kinds of stuff related to computing and storage. But I remember each of these milestones because this is when I started getting involved with storage. Soft PC for Sun and Mac OS was released by Insignia way back in '88. And we were just reminiscing this morning about the painful experience of running virtual PC on Macintoshes in the 90s, and remember that milestone when Connectix put that out to run Windows on Mac. VMware stepped into the game with some smart Stanford graduates and got their patents out for the VMware Virtual Platform in 1998 and really kick-started this industry into gear. In fact, EMC, just a couple years later, picked VMware up because of the attractiveness of the market they had created. And then, of course, with the growth of open source software, freeware, technically open source, not freeware, Zen was released, and Zen is an open source alternative to virtualization, which has since been picked up by Citrix and is being developed by Citrix. Parallels, if we remember that software, which is currently in the marketplace, that was released for Mac OS. And then in 2007, VMware went public. And this really, really, really brought the awareness to the computing world about virtualization, and VMware was dominating the market share at this point. And Microsoft jumped right back in with Hyper-V, which is a very attractive offering offered up in Windows Server since 2008. That is Microsoft's solution that actually offers some really tight integration with all the Microsoft products. And now VMware has just released vSphere 5.1 in the last 2 months, and that's their latest offering. So when we look at the history, virtualization's been around for 50 years. It's just become a really significant part of what we're doing in the recent past. So let's look at the pie chart for a moment and how it lays out in the global market as per IDC's statistics this year. And this comes directly from IDC. We can see that VMware's got the big piece of pie at almost 56%, but that's actually, from everything I understand, smaller than it was percentage-wise, and the Microsoft piece of the pie is actually growing. The Zen Citrix open source-based stuff has got a small section, and KVM, which is the kernel modification in Linux that allows some virtual computing, is making up part of that other category. But that's how the landscape lays right now globally on the deployment of virtualization as per IDC. And we can see here that VMware does have a pretty good handle on a big part of the industry. KVM that I referred to a moment ago, of course, with the Linux logo up in the upper right-hand corner, is a specific hypervisor that ties right into the hardware kernel extensions, which are pretty neat on AMD and Intel motherboards. VMware, the big logo in the center, of course, is larger, showing its dominance of the market, but the others shouldn't be ignored because there's a different application for a different type of user for each of these virtualization technologies. Some of which, of course, are free, including stuff from VMware on the lower end, but also paid and license fees for these. So let's look at VMware's dominance for just a moment in the market and the ecosystem it's created. There are vendor and hardware certifications very specific to VMware, and you've probably seen that logo from the last screen stamped on some of the products you either own or you resell. We see boxes from NAS manufacturers, small RAID manufacturers, whether it be Buffalo Technology, Data Robotics, or plenty of people in that space, up to all the high-end stuff, whether it be from Aberdeen or EMC. Of course, these certifications and this logo branding of VMware has been a real market product enhancement for those products that have been qualified for it. VMware also puts out a lot of training programs and technical certifications, and for all those people with a lot of acronyms already stacked up after their job title, the VMware, search from VMware are a good one to have on there as well. It's really interesting to watch this entire industry grow around a software product. I attended VMworld this last year, and really they have created their own industry and ecosystem of companies that were born simply to support and write software tools to support the VMware ecosystem. And primarily, these are enterprise customers that are running virtualization, not exclusively, but primarily. And what I mean by enterprise, at least in our world here, is any type of a multi-disk device, whether it be NAS, RAID, or SAN. And we see these coming from hospitals, from banks, from financial institutions, as well as small business. So what are some of the advantages of virtualization, and why is the market really digesting it at such a great rate? Well, first of all, there are cost reductions that are obvious in total server hardware required, smaller physical footprint, smaller data center footprint, fewer physical devices, lower power and energy costs. These are huge advantages. Maximizing processor power and network efficiency. The reality is that many servers have over-provisioned capacity and memory at any one time, and virtualization allows a VM to take full advantage of maximum resources as needed if they're provisioned properly. And the concept of shared storage pools, which can be the consolidation of all kinds of different storage devices into one larger SAN, ideally with multiple layered redundancy, and we'll get to that in just a moment. And one of the richest and neatest things that virtualization offers today are some of the tools to back up, snapshot, and replicate virtual machines simply for the concept of data protection. They know that data is lost from any type of device, and VMware and the other virtualization engines have created these technologies to help protect user data in the enterprise environments. So here's a good graphic for you that I think illustrates quite easily how this environment would be set up with a shared storage pool, which doesn't have to be, but would typically be a high-powered SAN or RAID device sitting at the bottom of that with some host computers connected to it, running a hypervisor layer, a VMFS layer, and on top of that, then running all those different virtual machines, which would all be sharing data or having separate isolated virtual disks on that shared storage pool. So one of the advantages I think is clear right there. But to talk to that replication and backup and migration concept we just touched on a moment ago, this diagram shows some of that rich and robust procedures and recovery options that are built into the software. Now, these are not the free tools, of course. These are part of your licensed paid stuff, but they can replicate the vSphere itself, the virtual machines contained within, and the storage at the bottom. Nonetheless, all these layers of protection don't prevent data loss in some of the worst case scenarios, and we're seeing plenty of it, as you'd imagine. So what are some of those disadvantages to consolidating resources, to figuring out how to remove some of those pieces that don't fit into the puzzle and get them all into one nice environment? Well, of course, the more eggs you place in one basket, the bigger the omelet when the basket falls. And this metaphor plays well in the virtualization space because it's absolutely true. If the SAN goes down, that storage area network that everything is connected to and virtual disks or shared data is on that SAN, well, all the VMs go down as well, or at least they all lose their storage. Or what if the host hardware goes down, the actual computing hardware itself, not the storage? All of those VMs that are hosted on that particular box, what if you got 12 of them? What if you have 24 of them? They all go down at once. Now, ideally, you have some replication in place as well so that you can bring new hardware up very quickly. But the reality is the consolidation of resources does add to the complexity if there is a failure where more hosts, more guests go down and one host goes down. So what about recovery challenges? You know, what are we concerned about here in the lab when we're having to deal with these? Well, first of all, these are almost always on a RAID or a SAN. They're complicated and unique configurations, and typically it's already an escalated support case with the OEM under some kind of service contract. The good news is the physical engineering is the same process at DriveSavers. We do reverse engineering in the laboratory and clean room. We resolve hardware and more complicated failures at the physical layer. But where it's different, and it's absolutely different, is in the logical engineering end because it's more complicated. The reality is there are always multiple virtual machines running on one piece of virtualization hardware. And what ends up happening is that instead of recovering one server environment from this, we might have to recover a dozen or 24 or even more virtual servers. So for one large physical recovery, we may need to do multiple logical recoveries, and each one of those can have its own level of complication. Also today, what's changed, at least in the VMware world, is the concept of thick versus thin provision volumes. I'm not going to go into great detail on that because it's its own little class, but if you have any questions about thick versus thin provisioning, we can take those offline, or you can find tons of information online about that as well. So a quick case study for you. This is a good one, and I'll get through it quickly, but it's important to understand. So, schools out. Well, it's not right now, but it was for this particular district. What happened was a school district with a clustered server setup, a storage area network, and VMware had a problem. It was running ESXi v4 on 3-year-old enterprise hardware under service contract, great running stuff with 12 VMs running. The hardware configuration was crazy. This was 2 large servers with failover redundancy, 2 racks, 14 different RAID 5s, 5 hard drives in each one. Why did we have to do data recovery on something with 14 RAID 5s with failover redundancy and clustering? Because 6 hard drives went offline out of 70 and created a staggering failure, a staggered failure with hardware issues. This caused a cascading failure of the SAN. And to add insult to injury, the admin on site aggravated the failure by making some very poor choices and actually bringing the second side of the cluster down. So it was a very ugly situation that they needed a resolution on very quickly. Well, for the kids involved, I don't know if it's good or bad, but school is back in session. This was a critical data loss situation that needed immediate attention. We got 2 crates with 70 hard drives shipped to DriveSavers ASAP to the lab here. We had full cooperation with OEM support in the service call history because they had been triaging this failure for some time before they called us in to help solve it. Engineering resources for the hardware recovery was significant. All source hard drives were imaged to sanitize target clones, which are empty drives. 6 failed hard drives required additional clean room engineering. Metadata corruption was significant, and all 14 RAID 5s needed to be logically rebuilt first. And then as a safety, those were imaged as well, just to protect ourselves during the data recovery process. And then logical recovery of the data, multiple VMs again running on top of this SAN. Each virtual machine, each server, virtual server, required individual recovery if it was corrupted from the media damage or the metadata corruption. And on-site field engineering support from the OEM was there to assist with the reintegration of the data when we shipped it all back and kept the backup here. So this is an excellent running required. Okay. Not sure if we dropped off there, but the significance of this particular case was that this system never should have gone down. It had multiple VMs running, it had multiple layers of redundancy, but nonetheless it turned it into a very significant large enterprise class data recovery. So it can happen to anybody at any time, even a big system that's protected. So what to remember about VMs? Well, this is fairly simple stuff. Virtualization concept, it's just multiple guest operating systems or computers running on common host hardware controlled by a hypervisor layer. So what if there is data loss or failure? Don't panic, and please don't try to fix the problem yourself unless you are heavily certified in VMware and you know what you're doing triaging a problem like that. Please check for backups or snapshots and attempt to restore only to another server that has not been affected, and check for hardware OEM or VMware service support contracts, because those people are great at helping to figure out whether or not you need professional data recovery. And of course, if the data is critical, as it was for that last customer, engage DriveSavers ASAP. The earlier we are involved, the higher the chance for data recovery in the end. So looking ahead, well, we always like to look down the road at DriveSavers because we want to be aware of what's coming next. Of course, more growth for virtualized computing environments. VMware's propriety and licensing schedules kind of got some people not so happy in the field, and because of some of their costs, they're losing ground to Microsoft. Since Microsoft includes Hyper-V in its server products right now, it appears as though users like free included software rather than having to pay for it directly. Virtualization in the cloud, just like SSD in the cloud, just like any other type of storage in the cloud, new versions of these virtualization engines are developed specifically for data center use and for cloud computing. In fact, the latest stuff from VMware specifically for that. And new technologies will always bring new challenges. We expect more security, more encryption, and more issues related to complex configurations. And of course, DriveSavers is always working on the next big thing in storage, whether it be an emerging technology or working with the installed base that's out there right now. Our ultimate goal is always the same. We want to offer the best and highest probability of reuniting your important users with their critical data. And in the virtualized world, VMware, Citrix, and Microsoft, we're doing exactly that on enterprise scale recoveries for all kinds of your users. So with that, I would just like to leave it open. Did we miss that one? There we go. For some Q&A. We ran a couple minutes long on the presentation. I hope that was okay for everybody. Covered a bunch of material there. But we're going to leave it open right now for some Q&A, and I appreciate all you being in the room. John?
All right, so now is the time to ask your questions, and you should have a panel in the GoToWebinar control panel on your machine where you can type in your questions, and we will read them aloud for everyone here so they can hear what the question is, and Chris will respond. Do we have any questions? Anyone going to type in that little box and ask us something about VMware and data recovery? We'll just wait here for a moment and see what happens. Okay. No questions so far. Okay.
John, let me throw one out there. For all the people in the room, are any of you currently running any virtualization, whether it be on the desktop for a single user workstation, or are you supporting it anywhere with your customers? I'm just curious. Okay, I see a couple people popping in there. Thank you so much for those responses. And for those few that I saw just now, oh, there's another one as well. That's good. That's good. Desktop and supporting customers with it. I'm not surprised about that. So one of the questions that just popped in, I'll grab it just really quickly here, was from Scott, and he asked about is recovery any different for different VM manufacturers? That's an excellent question. Yes, it definitely is, because each virtualization technology has its own underlying layer that's a little bit different. Now, once you get into, for example, the virtual machines themselves, VMware uses VMDK files, and we have different configurations with Xen and with Microsoft. But once you are actually addressing each individual VM itself, it's almost like a self-contained file system operating system. So once we get into the VM, the techniques for recovery are similar to if they were just a single file system on a single computer. The challenge is getting through the hypervisor layer or that underlying technology to get to the VMs themselves.
I have a question here. Actually, this was asked during the presentation. It's from Larry. He wanted to know, in the school district example that you had in the presentation, how long did it take for us to recover all the data after we were able to image the drives?
That's an excellent question. So in that particular case, we did, if you recall what I was talking, we did the physical layer recovery, and all of that imaging was done, I believe, in less than 2 days in the lab. Then the logical rebuilding of the RAID 5s themselves, the 14 different containers, that took an additional 2 days, I believe, from the engineering effort. And then what was sent back to the customer site were 70 clones of the original drives, not the 14 RAID 5s. And then at the customer site itself, it was the OEM's on-site engineering that reinstalled those 70 drives and then brought the RAIDs online and then brought the SAN online, and therefore the VMs on top of that. What we kept as a safety on the side were those original images of all the drives and then the images of the RAIDs And the on-site configuration and recovery, I believe, was also 2 days.
Tiki has typed in a question regarding the recovery of the rate set, which I think you just answered. Tiki, did that answer your question? If you can respond with a yes or no in the questions box. Yes, he says with an exclamation mark. All right. Next question. What were the mistakes made on site at the school district?
Ooh, excellent question. So one of the mistakes that was made on site was that the admin on site decided to change out a particular piece of hardware in that big SAN stack. And that piece of hardware was speculated to be bad, and it was actually a switch. It was a fiber switch. It was not data itself. It was a switch. That switch was taken down and replaced, and unfortunately, for reasons beyond what we can explain to you, uh, that caused further aggravation of that particular side of the cluster. What happened next was a configuration mistake by the customer in trying to attach to the other side of the cluster. The other side of the cluster should have been okay, actually. That's what's so ironic about this, and not needed recovery. But when the user attached to the other side of the cluster, they were unable to see the underlying file system due to corruption, and we were not on site at that time. Now, when the engineering support was brought on site to assist with the failure, that admin had already taken these steps, and they were not really reversible. So this is one of those cases where having a qualified service engineer on site with you to help coach you through those steps.
Okay. Here's a question. Since we're talking about VMware, is the recovery process any different for other types of VMware or VM manufacturers? Oh, you did. Okay. Chris answered that one already. Okay.
Yeah, I think I answered that one somewhat earlier. Yep, complicated on the stack layer, but once you get into the VMs themselves, they
Okay. All right. Any more questions? This is great. Good, very good questions. All right. We're running at about 33 minutes here. So if you have any final questions, now would be a good time. Well, here's another one from Tiki. He says, "What about I'm assuming SSD is what you're saying, Tiki. He's typed in SDD, but I know he means SSD. Are you saying SSD with regard to VMware? Solid state drives in terms of data recovery.
yeah, great question. And yeah, there's a direct application for SSDs right now in the virtualization space, especially in some of the cloud space where you can provision by purchasing or renting SSD-driven virtual machine cloud services. Specifically, by choice, you do that because of the extra compute power and the speed you get from running off of SSD. This, coupled with the fact that SSDs are now being designed specifically for the data center in mind, uh, yeah, absolutely. Solid state drives in virtualized environments are quite common right now, and the recoverability of those devices is the same as it is with all of our other SSD environments. uh, I don't know if you attended a webinar last year, but it's all about the controller on the SSD and understanding the controller technology as to whether or not an individual SSD is recoverable. And then, of course, in these environments, there's probably going to be a whole bunch of SSDs, or it's going to be a tiered environment where we've got some SSDs and some hard drives all mixed together in a storage pool or SAN with a hypervisor on top of it and VMs running on top of it. So long answer to your question, short answer is yes.
Did that answer your question, Tiki, or did you want to know more about the details specifically of DriveSavers process when we recover solid state drives outside of VMware? Details. Okay.
what we'll do is we'll send you the webinar on SSD that I did, because it's 30 minutes of nuts and bolts on SSD recovery, and hopefully that'll be able to answer your questions. So when we go offline here, we'll get that to you, and let me know if you have any follow-ups after that.
Okay, great. Well, thank you all for joining us for our